Hello. I'm afraid I'm going to have to interrupt my four-part series with an addendum. You know, like when a book is published and then they see some things that need to be corrected, but they've already printed the pages, so they do what they publish addendum pages. So this is an addendum podcast to make a correction. Now the correction is um, uh, the fact that I noticed that all through that uh, um, last podcast, part 3 on the triumph of modern science, I used the word, I referred to the Royal Academy as the first scientific society. And I noticed kept using Royal Academy. In fact, it's the Royal Society. So you know how you can learn something from your teachers, and you can also learn errors and mistakes. So please, no one, you follow me and refer to the Royal Society as the Royal Academy. Now, the Royal Academy, of course, Royal Society rather, it was headed by the King or the Queen of England. And this explains why a lot of the scientists and archaeologists are referred to as Sir, a knight. It's a knighthood, but they weren't soldiers or they weren't in the military, but they were knighted. They were given this title based on their scientific achievements, like Sir Isaac Newton, and or I think what is the female term is a dame, but anyway, they get these knighthood terms because they've been members of the first and scientific organization, and for many, many years, the most prestigious one. Now, I want to mention a indirect connection I have with a member of the Royal Society. This is the gentleman on the left you see on the slide, who I've already mentioned as mentioning that the history of philosophy is a series of footnotes to Plato. But Alfred North Whitehead, also, when I was a young person, our schools were bringing in what they called new math. Now, the new math was an attempt to put mathematics on a logical basis. And one of Alfred North Whitehead's students, Bertrand Russell, the guy, I think they were at Cambridge at the time, they worked together to do this until I mentioned the Gödel's theorem that proved that you can't do that. So they were not, that was an unsuccessful attempt. But Whitehead was a member of the Royal Society, and he, you know, he. I mean, at that time, people knew who Whitehead was. They didn't know this man right here. You probably know who he is, but he was a clerk in the patent office, and at this time, England or the Allies are at war with Germany, and so he was a German or scientist, but he had developed this theory of relativity, and his special relativity. People knew about it, but then he postulated this theory of general relativity, saying that the space is curved, and that gravity will actually cause the light to move in a circle or to bend. And during World War One, an astronomer from England went down the west coast of Africa during an eclipse. They could because the sun was dark, they could detect the light from behind the sun. We're going to see, is the sun going to bend the light? It was a test of Einstein's theory of general relativity, and when this happened, when the telegrams got back to England, it went to the Royal Society was meeting, and with a joint meeting, and the one who really understood things was Alfred North Whitehead. So Alfred North Whitehead, it was a really a dramatic event. He recognized that history was going to change with this, and so all of a sudden this man Albert Einstein became famous. So Alfred North Whitehead was very instrumental in bringing Albert Einstein to the attention of the world. Now, Whitehead later comes to Harvard University, and one of his students was Charles Hartshorne. Now, one of a mutual friend of Hartshorne and I, a professor here in Charlotte, and happened to be a teacher of religion at Davidson, Winthrop, and I met him. He was at University of North Carolina, Charlotte, teaching some courses, and Hartshorne, while he was at Harvard, was Whitehead had him to edit the papers of Charles Peirce, C.S. Peirce, who I've already mentioned he's really America's most influential philosopher and the scientist, and a lot of the things now used in computer science, a lot of the logic in artificial intelligence, and in the theory of language called semiotics. In Europe, our American philosopher C.S. Peirce, he's a real big figure, even though he's American. Maybe the only other American philosopher that might compete with him might be his student William James, or maybe Jonathan Edwards. But Peirce was Hartshorne and Paul Weiss edited Peirce's letter at collected works at Harvard. Now, at this time, what's significant is the only most philosophers at this time did not believe in God. The only two that did believe in God was Peirce, who was Anglican. He really believed that God was responsible for love. So it was a rather personal and sentimental recognition of God. But Whitehead recognized he needed God. We needed God in philosophy to explain how the world is held together. If there wasn't a single mind holding things together, there would be the world would just be fragmented. And so he saw God as a necessity to hold the world together. The other thing he saw was necessary is new things coming into the world. How do you explain these new things? And Whitehead said only God brings into these in novelty or new things. And so he had two reasons that he used God. Now his sense of his notion that the world is more organic was called process philosophy. And then the man at Harvard that picked it up was Charles Hartshorne. And there's pictured here Ian Barber. He was another philosopher of science that I've actually referred to some of his work. I didn't mention his name. John Cobb. This is called, it actually influenced theology, something called open theism, that's based on God knowing what has been happened, but not actually knowing everything about the future. It seems to give an answer to the problem of evil, so it's attracted a lot of people. It's really not compatible with the God of the Bible, and Hartshorne and I got introduced because our mutual friend knew, how he was just surprised to find this student of Charles S. Peirce here in Charlotte. And so I happened to be the recipient of one of the letters that Hartshorne wrote to my friend, and it was about this theory of relativity. Whitehead had also a rival theory of relativity, but it seems that Einstein had said that the world has to be connected physically, and that was the basis of him using the speed of light. You got to have some physical way for things to be able to influence one another. But if God knows everything that's going on, there's no physical way that could happen. But in the 70s, this physicist named J.S. Bell used the works of quantum physics to to show that if quantum physics is true, and if quantum physics is not true, our our things don't work. Um, um, uh, so people accept that quantum physics is true, but he proved that the world isn't really physical. It actually challenged Einstein's physicalist postulate, and at that time, the physicists, they they got religion. So I mean, maybe not the biologists and evolution or the psychologists. They didn't understand this, but physicists knew that the world was more than physical things. And of course, at that time, I had an encounter with the Lord, and I did not go into the Eastern religions, but this was a very important uh, uh, thing in the history of life. Now, uh, at this time, I had some of these philosophers in. I was connected to Charlotte, and you see these. It's called bubble patterns. This is from a quantum chamber. I had uh, sponsored this symposium on American thought. Had a lot of these process philosophers that came to Charlotte. Was well covered in the papers, and in my era of philosophy, I had gotten a letter, or my friend had gotten a letter from Hartshorne at that time about this Bell's theorem, and he said, "Praise the Lord, Nolan." That was our mutual friend. He said, "Bell may have the quantum physicists may have saved us. There might not be any spatially separated contemporaries, meaning that things are not, that Whitehead's God could be the case." And I almost immediately when I saw that, I realized Hartshorne's got a problem with this divine time, because the same quantum physics also shows that, Niels Bohr explained how the last position of electron determines the wavelength of the photon that's emitted when they jump. Basically, it's backward causation. The future is actually influencing the time of the present or the past. And you don't hear a lot about this, but I see it fits so well with the Bible. God, or Jesus, is both the Alpha and the Omega, the beginning and the end. But not only is he the beginning of everything, he is the end of everything, and he is influencing how things move towards himself, or towards the Father, towards God. But he can do so in such a way that doesn't take away freedom. In other words, God knows where things are going, but people can actually, we have some choice of how will fit in how things are going to eventually be. And Hartshorne, when he got my letter, he knew immediately that this was a problem, and he went to his colleague at the University of Texas, John Archibald Wheeler, for help with this. And Wheeler did work on it. In fact, it began to impact quantum, some developments in quantum physics after that. I wasn't, I'm not only, I left philosophy, I left physics when I had my encounter with the Lord, but it was I just thought you might enjoy this little connection between the Royal Society, which I forgot to mention, and uh, and what we're doing here and what I'm doing here in Charlotte now. Thank you.